Let us read this question from May 2018, paper 2. While I'm reading, I'm thinking of what information does the text give me. A 3D shape contains of a hollow sphere made of metal. So it's a sphere with a hole inside. Immediately brings me to the idea that if I know the radius of the big sphere and the radius of the small sphere, I can find the volume of the big sphere outside, the volume of the missing sphere inside, and therefore I can find the volume of the metal. Let's see what information I'm given. The diagram shows a cross-section drawn through the center O of the sphere. O, so I see the radius of the small sphere, which is missing inside, and this is a big sphere. The internal radius of a sphere is 1.2. When I read the question, I check the information on the diagram as well. The thickness of the metal is T centimeters. Again, while reading, I'm thinking, what can I do with this information? I cannot find numerically the numerical answer of the volume of a big sphere because I don't know its radius, but I can find it as an algebraic expression. Its radius will be 1.2 plus t. The radius of the small sphere, which is missing inside, is 1.2, so I can find the volume. Therefore, I can find in terms of t the volume of the metal. The density of the metal is 2,700 kilograms per meter cube, and I'm giving the mass. Okay, now, so I'm asked to find the value of t. Now I have a bit of problem of what to do with this one. I know that the density, which you can label whatever you want, I label it by the letter rho, is 2,700 kilograms per meter cube. When I see kilograms per meter cube, kilograms comes from the mass and meter cubes come from the volume. It's a unit of the volume. So the density is mass over volume. See, I don't remember the formula. I just look it from and retrieve it from the units. So my idea now is that I can find the volume in terms of T. I know the mass because they tell me that the mass is 1980, and I know the density, which is 2,700. I check the units. I have meters cube, so it's okay. And T, well, I'll find T in meters, and then I need to change it into centimeters. So see how this one gives me the equation from where I can find T. So let us look at the volume. Volume of a sphere is 4 over 3 pi r cubed. Therefore, the volume big is 4 over 3 pi, and the radius is 1.2 plus t, and the whole radius is cubed. Volume small is 4 over 3 pi times 1.2 cubed. So, going back to my formula there, the density is the mass over volume, and volume is volume big minus volume small. Now that's not an easy to manipulate equation, so what I can do first will be to get rid of the denominator by multiplying the denominator on both sides. So I have 2,700 volume big minus volume small, or outside and inside, is 1980. So volume big minus the volume small is 1980 over 2700. Now that's an equation I need to solve. 4 over 3 pi 1.2 plus t cubed minus 2 cubed equals, and my calculator gives me, when I put 1980 over 2700, gives me 11 over 15. Now I'm looking that I need to give my answer to significant figures, so I can move into decimals. And see, I'm looking, where is the unknown? The unknown is located here. So I need to isolate that expression. Here I have a number which I can calculate. Here is another number that I can calculate. Here is another number that I can calculate. So I will put in my calculator 4 over 3 pi, and then I put all this expression and replace it by a decimal, and this one and replace it by a decimal. Okay, that's what I've done. 4 over 3 pi is that decimal here. Well, I'm asked about two significant figures. I need to get an accurate answer, I need to take quite a few decimals. So I decided to take 5 decimal places. Even if you work with 3, you should get your answer correct to significant figures, but I chose more to be more accurate. Then all this expression put in my calculator give me that number, and this expression gives me this number. Now I will isolate this whole expression by first adding this to both sides and then divide it by that number. Okay, these are the next calculations. So step 1, step 2. So the next step will be to cube root both sides to get 1.2 plus 3, which is cube root of 1.90307, which will give me 1.2 plus t to be 1.23923, 6 significant figures. Therefore, t is 0.00 03923. Now I remember that I need to change it to centimeters. So actually t in the problem will be, I multiply by 100, so I get 3.922. Let me look back. I need two significant figures, meters, so with two significant figures will be 3.9 meters. When we turn over for the marking scheme, it seems to me that they forgot to change it to meters. Sorry, to centimeters. These are centimeters. And here is a marking scheme. Don't forget that these ones are meters and their answer needs to be in centimeter, but probably not get a mark off if you forget in this case. Now we can try ourselves this question, which is from the other paper of the same year. Please read the question carefully. This question is simpler than the previous one. You are just asked to calculate the density of the sphere, but see, in this case the formula is not given. So you should remember that formula for the exam, as it is not in your formula booklet. Here is the answer.